In this lesson, we're going to be talking about similar and congruent figures. A congruent figure is a figure or two figures that have the same shape and the same size. So they're basically two identical figures. They can be triangles or squares or rectangles or any type of other polygon, which is a closed figure. And the symbol that we use to recognize that two figures are congruent is this little symbol that you see here off to the right. So when you see that, that means that your two figures are both the same shape and the same size. Now, in order for two figures, I'm going to use the term polygon, and a polygon is just a closed figure, meaning that all of the edges kind of have a connecting point. So in order for a polygon or these figures to be congruent, two things have to be in line. Number one is they have to have corresponding angles that are congruent. And we know that congruent means the same shape and same size. So corresponding angles on the two figures have to basically be the same. And I'm going to show you some examples here today. And then the second thing is corresponding sides have to be congruent, meaning the side lengths of the figures, the corresponding side lengths have to be the same size and shape, or basically the same measurement. So if those two things come into play, then you have a congruent figure. Now, let's go ahead and talk about the word similar. Similar is a little bit different. Similar means that the two figures are going to have the same shape, but the size is going to be different, meaning one's going to be larger and one's going to be smaller. And the symbol we use for similar looks like this right here. So when you see that symbol, that means that the two shapes are similar. And sometimes your figures, let's say if, for example, you have two shapes and they don't necessarily look like one's bigger or smaller, but they give you this symbol that means similar. That means that it's not drawn to scale, meaning it's not drawn so that one looks larger than the other, but they are in fact similar and one's bigger than the other. Now, in order for two polygons to be similar, you have to have corresponding angles that are congruent. And that's very much the same as the word congruent. So those angles have to be the same. But the second one's a little bit different. In order for two figures to be similar, they have to have corresponding sides in proportion. And we're going to be talking about what that means here today. All right, let's just go ahead and start with the basics and talk about congruent figures. It says here, place markings on the triangles below to show that the sides and angles are congruent. So you can see a little bit of symbolism here. You can see that this symbol here means angle. So when you see that symbol, that means the angle measure of a specific letter is something. And we know that the interior of a triangle, those angles should add up to 180. But we're not going to be looking at that here today, just a good reference point. And then if you see something that looks like this, a little AB with a line over it, that means line segment. So the line segment AB. So let's take a look at this. The first one says, let's just look at the corresponding angles. It says here that angle A is congruent to angle L. And you can see on our two figures over to the right, this is angle A, and we're going to represent it like this with a little angle. This is how you represent an angle. This angle corresponds to angle L. These are corresponding angles on the two figures, and they are both congruent to each other, meaning they have the same angle measure. Let's go to the next one. Angle B is congruent to angle M. Okay, well, let's look back at our triangle over here. Now, instead of recognizing that, we're going to recognize that B and M are corresponding and they're congruent, but I can't just put one little angle measure symbol here because that would mean that B and A and L are all equal. But we want to recognize that B and M are equal. So I'm actually going to do 2 of these little loop-de-loops here to recognize that these 2 angles are corresponding and congruent. And then, of course, for the last one, angle C is congruent to angle N. We're going to use 3 little loop-de-loops to recognize that they are corresponding and congruent. Okay, now that we've done corresponding angles, let's go ahead and recognize the side lengths. So it says corresponding sides. So it looks like line AB is congruent to line LM. And here's how we're going to recognize this. I'm going to put a little line just like this. That's line segment AB. And that is going to be congruent to LM, which is right over here. I'm just going to put a little line segment. That marking shows me that these two line segments are congruent. Okay, and then how about the next one? BC is congruent to MN. So BC is right here. I'm going to use 2 little tick marks. And then MN is right over here. I'm going to use 2 little tick marks. And that tells us that those 2 side lengths are corresponding and congruent. And then the last one, CA is congruent to NL. Well, CA is right here, and NL is right here. And so by looking at these markings, you can tell whether or not these angles or side lengths are congruent, and they are, in fact, all congruent. Now let's go ahead a little deeper into the concept of similar figures. Now, it says here in the directions that the figures below are similar. And we want to write a similarity statement and fill in the blanks. Now, let me introduce to you a similarity statement. So what we're going to do is we're going to give a name to the first triangle. And I'm going to call it this. I'm going to call it triangle A, B, C. You see that? A, B, C is similar to triangle. Now, when I create the other part of the similarity statement, I have to do the same pencil moves. Let me show you what I mean. In the first triangle, I started at A, I went to B, and I went to C. And that's triangle ABC, and that always ends it just like that. We're going to do the same pencil moves with the other triangle. So I'm going to start with D, I'm going to go down to E, F, and finish. So this triangle is going to be triangle DEF. You see how I did that? Okay. Now what we want to do is we want to see which angle measures and side lengths correspond to one another. So let's look at angle A. Angle A corresponds to, well, we can see that angle A is right here, and he's going to correspond to angle D. Angle B is going to correspond to angle E. You see how this works? Angle C, that's this one, is going to correspond to angle F. Now let's look at the side lengths. Side length AB, that's this one right here, is going to correspond to side length DE. And it's also very important when you're doing side lengths that if you read it as AB, it's going to correspond to DE. It's not going to correspond to ED because that would be backwards. That would have to represent BA. It has to be the same pencil stroke that you do. So AB is going to correspond to DE. And BC, so BC is right here, is going to correspond to EF. And the last one, AC, that's this one, is going to correspond to DF. And there we just found the corresponding sides and angle lengths of these 2 similar figures. Now we're going to change things a little bit. We're going to rotate the figures. So notice here in number 3, we have 2 triangles, but this time they're kind of rotated. So let's first write a similarity statement and just start with one of the triangles. I usually start with the one on the left, and I'm going to call this triangle. We'll call this FGE. And you can see I started here at the top. I went down to the corner, and then I went to E, and then I'll finish it up. And so that's going to be similar to, and this is where I got to kind of think. You can see on this first triangle, I started at that kind of that pointy high point. That's going to be N on this triangle. So I'm going to go N to O to M and back. So this triangle will be N, O, M. Okay. Now let's go ahead and find the corresponding side lengths and angles of these two figures. So angle F, well, angle F is right here, and it's that pointy one. That's going to be our N. So let's go ahead and write that down. Let me erase this real quick. So angle F corresponds to angle N. Angle O, angle O corresponds to angle G. And this time, notice how I kind of flip-flopped it. Look at this, angle E. Well, angle E is way over here, and it's going to correspond to angle M. If it is easier for you, you can always kind of redraw the image, so kind of like this. And you can call this MNO. And so basically what I did was I took this triangle and I kind of stood it up so it would look like the other. You're welcome to redraw the figure if it makes it easier for you to find those corresponding sides and angles. Okay, now let's go ahead and take a look at the side lengths. EF, well, EF is right here, and that's going to correspond to MN. MO, here's MO, and that's going to correspond to EG. And be careful to make sure you write it as EG and not GE. And the last one, FG, here's FG, and that's going to correspond to NO. Okay. Now let's take a look at something called a similarity statement, which we've already created two of them, but let's go ahead and actually use it to answer the questions. This is kind of neat. So here we have a similarity statement saying that we have two triangles that are similar. One is called ABC and the other is called QRS. Now we can go ahead and draw these out if we like, but you don't necessarily have to. But if it helps you, you're more than welcome to. So let's go ahead and using our similarity statement, let's go ahead and determine the angle A corresponds to which angle. Watch how this works. Notice how angle A in the similarity statement is in the first position. You know what I mean by that? If this is 1, 2, and 3, this is 1, 2, and 3, it's in the first position. So it's going to correspond with the letter that is in the first position in the other triangle. So this is going to correspond to angle Q. See how that works? What about R, angle R? You can see angle R is in the second triangle and it's in the second position. So it's going to correspond to angle B. And angle C, you can see it's in the third position here. It's going to correspond to the third position in the other triangle. So angle S. So really, you don't ever really need two triangles or two figures. You just need a similarity statement to be able to determine those sides and angles. So let's look at some sides now. Side length AB corresponds to, well, here's AB. We want to find the letters that are in the exact same positions as AB in the first triangle. QR. Okay. How about RS? RS corresponds to BC. And this is my favorite one. This is kind of a little bit of a different one, so pay careful attention here. Line segment SQ. Well, notice how it's SQ. You went from the third position to the first position. I'm going to do that same thing with my pen on the first triangle. So I'm going to start at C and go to A. So this would correspond to CA. See how that works? Okay, let's keep going. Now let's go ahead and determine if figures are similar using proportions. And this is where we were talking about the side lengths of a similar figure must be in proportion with each other. Here's what I mean by that. Now let me show you here. It says determine if the figures are similar. Use ratios to prove your answer. Check if corresponding angles are congruent and corresponding sides are proportional. So in number 6, let's first go ahead and check to see if the angles are congruent. And they do look like they are. Notice this little symbol right here. This means that this is a right angle. And so most likely these two have the same angle measures within them. So check. Now here's how you determine if they have corresponding sides that are proportional. So I'm going to go ahead and indicate, I'm going to kind of give my triangles a name. I'm going to give this triangle, I'm going to call this the small triangle. I'm going to call this the large triangle. Or you could call them triangle 1 and 2 or figure 1, figure 2. It really doesn't matter. And I'm going to go ahead and write a word ratio here. I'm going to compare the small triangle to the large triangle. And what we want to do is look at the corresponding side lengths. So look at the corresponding side lengths here. So this side length here is going to correspond to this side length here. So on the small triangle, that side length was 3. On the large triangle, that side length was 6. Okay? Now let's do that with the other side length. Look at this side length. 4 corresponds to 8. So on the small triangle, I have a 4, and on the large, I have an 8. Now, the question is, are these side lengths proportional? And what I mean by that is simplify these two fractions. So 3/6, well, 3/6 we know simplify to 1/2, right? And 4/8 also simplifies down to 1/2. Since they both simplify down to the same ratio, they are in proportion with each other. So I'm going to circle yes. Let's take a look at another example. Okay, let's look at large and small again. I'm going to call this one my small and this one my large. And I'll set up my word ratio here. So small and large. And let's go ahead and set it up. Okay, this side length here, actually, let's talk about the angles first. Notice how the angle measures, I have 90-degree angles, which means that this is a rectangle. So all those angles are 90 degrees. So they all are congruent. Now let's look at the side lengths. Side length 7 corresponds to side length 14. So 7/14. And then the other one, side length 9 and side length 18. Well, 9/18 are those two corresponding side lengths. And if we were to simplify these down, you can see that 7/14 is again 1/2. And 9/18 again is 1/2. And it's not always going to be a half. It could be a third or a fourth, or it can even simplify down to a single integer. As long as they are the same when you simplify them, they are proportional. So these two are proportional. Now let me show you one that's not proportional so you can see an example of that. So here's my small and here's my large. So I'm going to go ahead and indicate that. And my angle measures are congruent. So let's go ahead and set up the side lengths. So my side length 5 is the same, corresponds with 20. So 5/20. And then the other one will be 8 and 10. Okay, now take a look at these fractions. Let's simplify these fractions down to their simplest form. 5/20 is going to simplify down to 1/4. But 8/10, well, it looks like both of these numbers are divisible by 2. So that would be 4/5. And 1/4 and 4/5 are not the same. So these two, even though they look like they're similar, they're not, because their side lengths are not in proportion with each other. So I'm going to circle no for this one. And that's how you determine if they are truly similar or not. Okay, the last thing we're going to do in this lesson here today is we're going to take a look at some similarity statements, and we're going to see if these proportions are going to create similar they're going to represent similar proportions. So let's look at number 9. And number 9 is going to go with this first A, B, and C. So we have similarity statement. We have triangle CAT is similar to triangle DOG, so cat and dog. And let's look below. Look at A. We want to fill in the blank of this proportion. So let's look here. AT is similar to OG. That works. You see that? Going from the first triangle to the second. Then we're going to do CA. Well, CA, what could we fill in the blank? DO, right? We want to have the same pen stroke as we work these problems. Let's try another. Okay, so this time my blank is in the top left, so I'm going to go ahead and start on the top right. So I have DO is similar to is equal to OG. Notice how that ratio was all on the same triangle. So that means on the left side, it's going to be on the other triangle. So AT, right, that's kind of like the OG, should be the same as CA. See how that works? Okay, let's try another. DO over CA equals something over AC. So wouldn't that be OD going backwards? See how that works? All about the pen stroke. Let's try another. This time I give you a quadrilateral, and I know it's a quadrilateral because not only the little symbol, but it has 4 angles. So ABCD is similar to LMNO. So let's look here. MN, so there's MN over BC, and then we have NO is going to correspond to CD. And you're welcome to do what I'm doing, and you kind of put your pen to the paper. So here I'm going to start with CD. So CD is the same as NO. And so AB is going to be the same as LM. All right. And the last one here, BC over MN. And then I have LM is going to correspond to AB. All right. And that brings us to the end of our lesson on similar and congruent figures.